Good morning, or afternoon, or evening, depending when you're watching this. Today we're going to talk about forces as vectors. Forces, in fact, are vectors, so we're going to solve a couple questions using them in that regard. So if you can come around here. Example 2 from page 355 is in front of you, and we're going to talk about two forces with magnitudes of 20 newtons and 40 newtons acting at a 30-degree angle to each other. We're going to determine the resultant of those forces. So first we're going to draw a diagram. This is the original 20 newton force, and this is the original 40 newton force. We draw a 30-degree angle in between them, and we see that in order to add these two vectors, we can actually draw them tip to tail instead of tail to tail, which we must do when discussing the angle in between them. We can draw them tip to tail when adding them, and we see that we have a 150-degree angle between F1 and F2. So we can use a cosine law here and figure out the magnitude of the resultant force. By plugging these numbers in, we get the magnitude of the resultant force quantity squared is 3,385.64 approximately. We take the square root of that and we get a resultant force of 58.19 newtons. Okay, now we talk next about our angle in between them, because we're asked to find the resultant force, and force has magnitude and direction. Now you see the answer here. The answer is 20.1 degrees. I want you to pretend you don't see that. This is actually take 2, and so we actually did a take prior and that didn't quite work out. So we're going to use a sine law to figure out the magnitude of this angle right here. So setting up our sine law, we see the magnitude of the resultant force over sine 150, in other words 58.19 over sine 150, is going to equal 40 over sine theta. So doing some fairly straightforward math, we get that theta is going to equal 20.1 degrees. So if we were discussing north, south, east, and west, it would be kind of easy at this point to maybe just state a direction for this vector. But unfortunately, we're not given any standardized reference system like north, south, east, and west, or like a Cartesian plane. So we're going to have to discuss the resultant vector in terms of the two component vectors. So we know that this resultant vector makes an angle of 20.1 degrees with the initial force of 20 newtons, and we can therefore figure out that it must also make an angle of 9.9 degrees with the initial force of 40 newtons, because the angle in between them is 30 degrees as described in the question. So our final statement, written correctly, is the resultant force has a magnitude of approximately 58.19 newtons at an angle of 20.1 degrees with the 20 newton force and an angle of 9.9 degrees with the 40 newton force. And by expressing it this way, we've given the direction as best we can. Moving on to the next question, we have here a situation where Kayla is pulling on a rope attached to her sleigh, and she's applying a force of 200 newtons. Now this rope makes an angle of 20 degrees with the horizontal, and we want to determine the force pulling the sleigh forward and the force that tends to lift the sleigh. So we begin by drawing our diagram. Here's the horizontal, and Kayla's pulling at an angle of 20 degrees with it. Well, we're going to write this out describing our horizontal component and our vertical component of that force. Now clearly horizontal and vertical have an angle of 90 degrees in between them, so we're okay there. But when we move this vertical force over here, we see that there's an angle of 90 degrees there as well. In doing that, we're able to use some basic trigonometry, SOHCAHTOA if you wish, or the winding function if you wish. And we're able to say that the cosine of 20 degrees is equal to the vertical component, magnitude, over 200 newton original force. And we can therefore say that the up here this should have said the horizontal component, my bad. The cosine of 20 degrees is the horizontal component over the original 200 newton force. So we see that the horizontal component is equal to 200 times cos 20, and we're measured in newtons. So 200 times the cosine of 20 is approximately 187.94 newtons. So she's, much of the 200 newtons is going in a horizontal direction for Kayla. Now we can also discuss the vertical component. Now the vertical component in our original diagram we can set up by using the sine ratio. The sine of 20 is equal to the vertical component over 200 newtons. So coming down here again, we see we have 200 times sine 20, and again measured in newtons, which is approximately equal to 68.40 newtons. So now we've established that the force that pulls the sleigh forward is 187.94 newtons. Remember I said this was take two? Well, this is why. 187.94 newtons. And the force that tends to lift the sleigh is approximately 68.40 newtons. And that is all for Math Corner